Hi, I'm Paul. We're doing Leetcode Must Know interview questions, and today's challenge is letter combinations of a phone number. Rated, medium, given a string of digits from two, actually, let me scoot this over a little bit so we can see the whole method signature. We get as input a string of digits. We'll look at an example of that as well. But a string of digits from 2 through 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. The mapping of digits to letters, just like on telephone buttons, is given below. Note that 1 does not map to any letters. Do cell phones still have that? Hang on. Oh, they do. Okay. Example. This is a good example. We can solve this. What are the topics for this? Hash table, string, backtracking. I guess you could use a hash table. I guess you could use a hash table to map the digits to the letters. Wasn't thinking of doing that. Just because I think it's harder to initialize. Well, I don't know. It doesn't seem like a backtracking problem. In fact, it's listed on Leetcode under the category backtracking, but I'm not sure why we would have to backtrack, why we couldn't just build it up, going forward. For example, let's take this one here, 2, 3. Those are the digits. So we could do this with a Q, right? If we have a Q, just initialize the Q with an empty string, and then we'll take the first digit, dequeue the empty string, and add, in turn, each letter of the digit 2, and then requeue it. So we'll add A and requeue it, B, requeue it, C, requeue it. So now in the queue we have A, B, and C, and we move to the next digit, 3. All right. So in turn we dequeue the A and we create AD, AE, AF. We put those. Actually, at that point we know that we're done because the results would have the same length as the input. So we could just put those in the result list. But okay, then dequeue the B and add the D. So we got BD, we have BE, we have BF. dequeue the C, we have CD, CE, CF, and we're done. I don't really see any backtracking. Anyway, let's see what an implementation might look like. Well, we need a list to return. So list string, call it result equals new array list. I think, you know what, let me check the constraints here. Oh, there's an example. Okay, so if digits is empty, which it might be, then we just return the empty list. Okay, so go ahead and do that. If digits dot length equals 0, return result. Done. All right, now we need a queue. So let's say we can use a, oh gosh, we can use a deck of strings. We'll call it Q equals new array deck. And we'll say Q dot add empty string. Okay. It's occurring to me that well, actually, it's occurring to me that I forgot a parentheses there, but also that it would probably be easier to deal with this input string as a character array, the digits. So why don't we say char, we'll say char digits equals digits dot to char array. Okay. And the other thing we need, okay, so we could char digits to char array. Well, we need some way to map the let's do this, map character string, just call it map equals new hash map. All right, now I've got to initialize the hash map. It's going to be kind of boring to type that, so let me just pause this. I'll type it and then come back. All right, so we've got an initialized hash map. You know what? I actually like offer better on that. All right, so I think that's everything we need to get started. The Q is initialized, so we can say while not Q is empty. Well, Q is not empty. Let's take the first string out. String S equals Q dot poll. If the length, let's see, if the length of that is equal to the length of the input string, then we have a complete combination. So the length is equal to the length, and you know what? There's too many parentheses. No, that's okay. No, it's okay. Then result, third try, add S. Okay. If we're not done, then we need to get something from the hash. We need to get something from the hash map. All right, let's try it like this. String chars equals map dot get. What am I getting? I need something from char digits array, right? Map get. So it would be char digits and s dot length. So that is going to, let's see. Okay, so the first time through, it'll get the first char digit. Second time through, it'll get the second char digit. Yeah, that should work. So we've got that. Let's say for char C in chars to char array. We're going to add each of them to this string and then requeue it. Okay. Say q dot offer s plus c. Okay. And then requeue it, and as they come off and at the right length, we add it to result, and then finally at the end of that, we can return the result. All right, let's get this one more time. So we have digits coming in. We've got our result list. If the input string is empty, just return the empty list. We get the digits into a char array. We get a hash map of phone digits to letters. We've got a queue. We start the queue with an empty string. While it's not empty, dequeue something. If the length equals digits.length, then we've got a complete combination. Put it in the result. Otherwise, do a map lookup using char digits and the length of the current string. All right. Once we have that, do the hash map lookup, and then based on what we get back, add each of those letters in turn to the current string and requeue it. I don't know. That looks like it's worth a try. All right. Go. Whoa. Kind of surprised. First time. Okay. Let's submit. Wow. What the heck? I didn't think it was that bad an algorithm. I wasn't going to use it. I don't know. I don't know what's taking so much time there. I don't know how you could do it without the queue. I don't know. Well, complexity. I mean, the complexity, it is, I don't know, 4 to the n. Worst case, every number, there's 4 possibilities, 4 to the n. What is the complexity of this? 4 to the n. 4 to the n times n. Why am I getting the times n? All right, well, I'm going to have to look at that. 4 to the n times n. All right. Well, let me try and run this one more time. I hope it doesn't get worse. No. A little bit better, 5 milliseconds. But most people are way down here. All right, look at this, see if there's some kind of backtracking algorithm that in fact is faster than just queuing them. But anyway, it still goes in the scoreboard as a win, and in the scorebook, I should say. And that's it. Feel free to subscribe, like, comment, and see you next time.